Dear students, today we are going to learn chemical bonding, right? So it is the basic lesson, or you can tell it is a backbone of inorganic chemistry. In first year we will study S block and P block. In plus 2 we study P block, then D and F block, then coordination chemistry. For all this lesson, this chemical bonding is the basic concepts lies there. Okay? So what is bonding? Bonding means it's a force of attraction which binds the atoms or molecules in the chemical species. Okay? So first one, bonding. It is the force of bonding. It is the force of attraction. Force of attraction which binds the atoms, ions, etc. in the species. Okay. Now we can see first one, what is the reason for formation of bond? So reason for bond formation. Reason for bond formation. First point is to complete its octet, or you can tell this one, to attain stability. To attain stability. Second one is decrease in potential energy. Decrease in potential energy. Okay? See here, there is a graph. We studied the reason for bond formation. Potential energy decreases. So let us see how the potential energy decreases. So you see here, these two hydrogen atoms. Okay? When two hydrogen atoms, they are far away from each other, when two hydrogen atoms, when they are far away from each other, there is no attractive forces. Okay? So you see the graph, this is 0, here negative sign, this is a positive sign. So almost the potential energy is 0. So when they come closer to each other, what happened this one? The potential energy, you see the graph, the potential energy decreases. From 0 still it is coming down. Then after some time, you see again when it comes closer to each other, what is forming? H2 molecule is formed. When H2 molecule is formed, the potential energy becomes still less. That means minimum bond energy is there. So when bond formation, during bond formation, the potential energy reaches minimum. So when the lowest bond energy in which the H2 molecule is formed. So just I am writing now, you see, when two hydrogen atoms approach, when two hydrogen atoms are away from each other, there is no attractive forces. Here potential energy is 0, right? When they come closer to each other, still when they come closer, potential energy decreases. Okay? Then when they form H2 molecule, potential energy becomes least value. Okay, here you see this is internuclear distance, this axis, here potential energy. This is nucleus. This area is atomic or overlapping of atomic orbitals. So here you see they become least value. Okay, so again you try to bring the molecules still closer to each other. What happened this one? There is a drastic change in potential energy. The potential energy, you see, it is going up and up. That means it becomes high value. So see here, when you bring the molecules closer, bring the atoms closer, what happens? There is a drastic change. There is a drastic change in potential energy. That means it increases. Okay, so now let us see this based upon this one. Now first in 1916, Lewis and Koschel, they have given explanation, logical explanation based upon valency and the inertness of the configuration. Okay, so inertness means we know inert noble gas configuration. So stable configuration, noble gases, they have stable configuration. That means outermost shell, they have how many electrons? 8 electrons, right? So here you see Lewis and Koschel, they have given this one. They have given importance to valence electrons. Because if you take atom like sodium, what is the electronic configuration? 2, 8, 1, right? So in 2, 8, 1, they say this one, suppose this is a nucleus, right? Then this first shell, how many electrons are there? 2 electrons. The next, how many electrons are there? 8 electron. 1, 2, 3, 4, 5, 6, 7, 8 electron. The remaining, what is this one? 1 electron. This electron is here. Okay, so they say this one, these atoms are like kernels. Atoms are like kernels. Kernels. That means this is valence shell, valence electrons. Nucleus, see here, nucleus plus inner core electrons, together form kernels. Okay, so here what this a nucleus is there, inner core means here 2 electron, again 8 electron. So total 2, 8. That means 2 plus 8 is equal to 10 electron. So 10 electron plus nucleus plus 10 electrons, they form the kernels. Okay, so valence electrons are outside. So what they say this one, they assume this one cube like that. Suppose we will study in solid state cube. So here how many valence electrons are there? Only 1 valence electron. This 1 valence electron, they occupy any one corner of the cube. Right? Suppose you take inert gases. Inert gases, you can tell inert gases 2, 8, helium, neon. So in case of neon, how many are there? 8 electrons are there. These 8 electrons, they occupy 8 corners of the cube. Okay, this is actually the first logical explanation given by Lewis and Koschel. Okay, now let us see electron dot structure. So what is electron dot structure? this you might have studied in 10th standard or 9th standard. Electron, Lewis dot structure. That means we are representing the electrons. We are representing the valence electrons by dot. For example, why we represent valence electron by dot? According to him, valence electrons only take part in bond formation. Other electrons, that means we study inner core electrons. They do not take part in bond formation. That means inner core electrons are protected by valence electrons, right? So first again we can take sodium or chlorine or something. Suppose for example again we can take sodium. So 2, 8, 1. So this is nucleus. So this is valence electron. Already I have drawn that one. So this is a valence electron. So Lewis has represented sodium by 1 dot. Then this valence electron is represented by dot. In case of calcium, how you represent calcium? 2. So 2, 8, 2. This is, so we can write like this, but writing like this gives some good look. Okay, just some formation. Then you can take in case of chlorine. Chlorine, what this one? 2, 8, 7. The 7 electrons are represented by Cl. 1, 2, 3, 4, 5, 6, 7. Then you go for neon. Neon, what this one? 2, 8. So how you give this one? Neon. 1, 2, 3, 4, 5, 6, 7, 8. So these are Lewis symbols, or we can say it is a Lewis dot structure. So what is the significance of Lewis dot structure? Okay, so first one, let us see. I think you understood this one, how to represent the valence electrons. So valence electrons are more important. So he has represented the only valence electron, the outermost electron, in the form of dot. So that is called Lewis dot structure. So what is the next? We can go for the significance of Lewis dot structure. Significance of, second one, significance of Lewis dot structure. Lewis dot structure. Okay, number 1, actually it gives the from valence electron, it helps us to find out, we can find out the valence electron. We can find out the valence electron. Valence electrons. From valence electron, we can find out valency, right? Second one is called, we can find out the group. We can find out the group of these elements. Group of these elements. For example, we can come to sodium. Sodium, what this one? 2, 8, 1. So first in periodic table you might have studied in 1, what is happening here? This is the valence electron. So from this we can understand this belongs to first group. Okay, either number of valence electron is equal to group. Second one, what we can understand? Otherwise, 8 minus valence electron. 8 minus valence electron. That gives the valency. Right? Okay. Okay, children, today what we studied, chemical bonding. First our point was what is bonding, right? Next one, what is the reason for bond formation? Okay, third one, we studied what is the theory for Lewis and Koshel theory. Explanation given by Lewis and Koshel. Third one, we studied how to represent Lewis dot structure or Lewis dot symbol. Okay, the valence electrons are represented by dot structure. Okay, then significance of Lewis dot structure. So today we conclude the class. The next remaining we'll see in the next class. Okay, thank you children.